See in the left hand corner of your screen, this is how you will get an icon on your desktop, right? Green color and micro 5 written, right? Microvision 5 will be written. When you click on that icon, you will get a window something like this, right? There might be some program, by default some program will appear on your screen, right? Whenever you start fresh, please close whatever program is there before. So if any earlier program is visible in your window, so please close it. So we will first go for project and close project. I should have a blank workspace, correct? This is how my workspace should appear. On the left hand side is your project workspace window. At the center, gray color is your text window, and at the bottom you have a console where you will get errors, warnings, and so on. So that's at the bottom, right? So your project, there should be a blank workspace. Now see Keil software. This is Keil Microvision 5, right? This is called as integrated development environment. It means multiple softwares are put together under this Keil Microvision 5, and hence the name integrated development environment. What all softwares you all have in this? You all have a compiler. You all have a C compiler. So compiler is the one we will be writing programs in embedded C. So that C program is a high level language. That high level language is converted into machine language. Correct? That job is of a compiler. Compiler converts a high level embedded C program into a machine language program, which we call it as an object code. So it has a C51 compiler. It has an assembler. Whatever assembly program I'll be writing, MOV, ADD, this language is an assembly language. So this assembly language program will be converted into machine language. So there is an assembler inbuilt, correct? After writing the program, you will check for any errors, warnings, and then you will run the program. So you have a debugger, right? So debugging is executing the program. Execution can be line wise, line by line. So that is called interpreter, correct? Line by line execution is called interpreter. If you execute all 100 line program in one go, that is called block execution, burst execution, and line by line execution. So all the three options are available. So you have an interpreter, you have a debugger. So all next you have a text window will appear where you will write the program. So you have a text editor. So all these softwares brought together under one, hence the name integrated development environment. Correct, students? So you have a compiler in it, you have an assembler, you have a text editor, fine. You have a debugger, line by line, burst, as well as block. Hence it is called as integrated development environment, IDE, correct? That's Keil Microvision 5. Now we are starting with how do we write programs. So my first step is a blank workspace. Next, we go to project, new Microvision project, and I will create a folder, right? I have already created an 8051, see here, in my D drive, or else I'll create it again, right? So I'll go to my D drive, right? I'll create a new folder and I will say 8051 programs. Do not give space whenever you name any folder or whenever you name your code. So I created one folder first, and inside that folder I will create practical one or example one, ex1. And inside example one, I will write a small addition program. So I will write my ADD program. Okay. Please have separate folders for separate programs. Okay. So I created my folder first, 8051 program. Inside that 8051 program, I created another folder, example1, and inside example1, I'm writing the code. So I did write my ADD. That's the name of the project. Now automatically a window appeared. It is telling me what device are you using. Are you using 8051 microcontroller, 8052 microcontroller? So you have to select the device for the target. So see, all these are microcontroller manufacturing companies, right? Whatever you see here, I'm just scrolling it down. All these are microcontroller companies. Among them, I am selecting microchip. So I come down A, B, C, D, F, G, H, I, J, K, L, M, N. So see here, microchip. Can you see this, students? I'll click on that microchip and select AT89C51 microcontroller. So can you see this? AT89C51. So it is describing what is inside 89C51. Fully static CMOS controller, 32 IO lines, 2 timers, and so on. That's the internal structure. So I went to microchip. I selected AT89C51 device. There is other option, generic. You can go under generic and select 89C51. I'm selecting 89 because it's a reprogrammable device. 9, correct? It's a reprogrammable device, hence 8089C51. So you go to microchip, select 8089C51, or there will be generic tab. Go to generic, select 89C51, or you can go to Philips NXP. So these are the widely used Philips microcontroller or Atmel microcontroller. Right? So select the device. Okay. It is asking, do you want this startup to be added in your code? No, I will write program from fresh. I myself will decide the memory location. I myself will decide the stack, everything. So I don't want this startup. So I will click on no. Whenever you write C programs, I want the startup file. And what is in that startup file? Predefined memory locations. Mean the stack location is predefined, ROM memory is predefined, right? So that startup file has predefined initializations of memory. We require this when we write C program, embedded C programs. When I write assembly programs, I on my own can fix up everything. Correct? So when you write assembly program, startup, do you want startup? No. And that's how you get your workspace created. See here on the left hand side, a target folder is created. Right? Right click on that target folder, options for target, and go to the output tab, the third tab, and see create hex file. It should be activated. So click on that. Right? Initially it is like this. Click on that, create hex file. A tick should, and click on OK. See, whatever program you write, you are going to put that program inside the microcontroller. So I need an hex file. Hex is an executable file. So my software will also create an executable file, and that is called as an hex file. So by default, that option is deactivated, right? So you should click on that, create hex file. Many a times, if your program is not getting converted into an hex file, it is of no use. Correct? So make an habit, whether you're going to put inside microcontroller or no. That's a last lookout. But every time I will make sure my program is getting converted into an executable hex file. Okay, students? So what did I do? Target, right click, options for target, the third option output, and I tick on create hex file. Okay. Now I am ready to write the program. So go to file, new. A text window appears. See, below that file, there's a shortcut. If you click on that, you get a text window. Right? And now I will start writing my program. I will write a simple add program. We will execute that and see. Okay, students? Small, capital does not matter. You write any way you want. I am just writing capital. You can write it in small case also. So I write org000 hex, right? Now, in this Microvision 5, indentation does not matter, but earlier version Microvision 3, it required indentation. So I have that habit of whatever program instruction I write, I give an indent. Whereas labels, I will start from the first column. See, this is the first column, and on giving a tab, I get an indent. So in the first column, I start with labels, and with a tab, I start with the program, right? Now, org00 is not an instruction. It is an assembler directive. Org stands for originate. Originate the program from this address. I told you all we should always start with 00 hex. So this is an assembler directive. It is not an instruction, right? So org, assembler directive, it is indicating, it is giving some directions to the assembler, correct? It is telling assembler your program begins at an address 000. It is a direction to an assembler. Microcontroller does not understand this. Okay. Now we will originate from 00, and from there we will immediately jump, because 00 onwards there are interrupt vector locations. We should skip that, correct? So I'll be writing sjmp jump to some label, sjmp start. I can give anything. So this is a label start, whereas sjmp small jump is an instruction. Okay, students. So org00 sjump start, and I begin my program with that label start colon. Okay. Start is a label. It begins from the first column. Okay. And then I give a tab and I start with my instruction. Now just simple MOV, I take one number in accumulator, MOV a comma hash. I will write 12 hex, right? Tab add a comma hash 22 hex. I'm just putting some number. I put 12 hex in accumulator. I added 12 hex with 22 hex, and I stop my program. There is no end instruction. In 8086, INT3 was the last instruction. So here, how do we stop? sjump, and I give some label stop stop. This is a label, correct? So sjump means jump somewhere, unconditional jump. Where? To this label. So I want to stop my program. So the label, I give it to the same instruction. Okay, students. So sjump stop. And where is the stop? To the same instruction. So microcontroller will keep on executing this. It will not go ahead to execute garbage instructions. Okay, this is the way you stop your program. Sjump, some label, and the label is to the same instruction. Now stop and start is just an indicator, right? I could also write here sjump xyz, and that xyz will come to the same instruction xyz. Okay, but this is something I should put labels which will give me some indication. So when I see at stop, I remember that is something to be stop. I should not go ahead. So the label should be indicative. So I stop my program, and the last one is END. So this is again an assembler directive. It is telling assembler your program is ending here. Okay, so the first statement and the last statement are for assembler. Start from this 000 hex. Whatever program is written ahead, convert it into machine language and stop the conversion here. Okay, students, my program is written. I go to file, save as. I should give the same name. Okay, where was I? I was into my D drive. I had written 8051 programs, 8051 program. In that I had example 1. and the name was given by as my add. So the same name dot a. Capital small does not matter, I told you all. A for assembly. C program asta, so I would have written dot C. Okay, so the program is saved. Now this program, see what is my program? My add.a. I should see in the workspace. So how do I bring that? See, this is how it will look. Target, click on that plus sign. You will see source group. Right click on the source group. Add existing file. My add.a. Click on it. Add close. See, now you are able to see your program. So that's your workspace. I should see my program in the workspace. Okay, students. Now I should check for errors. Right click on that, build target. See the console. It is showing 0 error, 0 warning, creating hex file. Hex file is created and there is no error, no warning. Okay. See, if by mistake, if I would have written something wrong, if I would have written something like, if I write AD, something like this, this will give me an error. Whatever changes you do, save, click on that, right click on it, build target. So see, it is showing an error. Line number 4. See, I have highlighted in blue color. Line number 4, error, undefined symbol. It didn't understand that AD. Took it as a label. So this way it will. What was that written? #22 hex I had written. Okay, students. I have made a change. I save it. Right click, build target. Hex file created, 0 error, 0 warning. There are no syntax errors. Now I'll run the program. So run debug, start debug. This is telling evaluation version. So 2 KB is the size limit. Okay, no problem. So see, your windows got changed. Right? So can you see in that yellow color? Your assembly program got converted into hexadecimal. SJMP, the code is, machine code is 8000. MOV A, 12, the machine code is 7412. Opcode and the operand. So upper one is called disassembly window. And the lower one, see, you can see that arrow, blue arrow and the yellow arrow, this is your program. Okay. Now execution, debug, start, run, at a time execute, step, one by one execute, step over, it means block execution. First 10 instructions, next 10 instructions. The shortcut is F11. Right. So I will click on the program and I will press F11. F11 म्हणजे पहिली instruction execute होईल. ती म्हणजे कोणती? Jump. So this is jump. Where did it jump? To label start. ती मी पुढे लगेचच लिहिली आहे. So the arrow came to start label. परत F11 केलं तर काय होईल? 12 hex accumulator मध्ये दिसायला लागेल. So F11, see students, blue color, accumulator मध्ये 12 दिसायला लागलं. So 12 hex got copied in accumulator. परत F11 केलं तर काय होईल? Add execute होईल. 12 plus 22 and the result will be in accumulator. So 12 plus 22, 2 plus 2 is 4 in hex, 2 plus 1 is 3. So the answer will be 34 hex. So I press F11 again and see the answer 34. And see, PSW got affected. Whatever is affected, that gets highlighted in blue color. So PSW affect झाला. So click on that. PSW is flag. Click on that and see parity, that's F1 user defined, overflow, RS register select, F0 flag user defined flag 0, auxiliary carry. So काय affect झाला? Parity got affected. Okay, students. So PSW, that was a flag register. You expand that and see which flags have set, which flags have cleared. What is my answer? Answer is an accumulator. What was that? 34. आता परत F11 press केलात तर it is executing stop instruction. S jump कुठे? S jump लाच. जम्प त्याच इन्स्ट्रक्शनला जम्प करत आहे. हे असं का करायचं? बिकॉज सी सम रॅन्डम might be there in your program memory, and if you do not do this, it will go on executing the instructions which are random, and they might change your answer. हे व्हायला नको म्हणून we are stopping microcontroller. कसं स्टॉप करतोय? Jump to the same instruction, jump to the jump instruction, unconditional jump, and that's how you execute your program, students. ठीक है? This is the register window where you will be able to see all the changes on the left hand side. Registers कोणकोणते? R0 to R7, accumulator, B, stack pointer, top of stack, DPTR, program counter, how many time period is required, states, how much time in seconds, and that's the flag. Okay, students? And see on the right hand side down, this is the stack. Besides it, it's a memory, right? I for internal, X for external. We will see all this. But in the debug window, you will see the machine code, that is disassembly. You will see your program, that is assembly language. Right hand side are the registers, and on the right hand side you can see memory. Okay. Now see, there's a tab called peripheral. Here you will see all interrupts, ports, port 0, port 1, port 2. Click kelat, so you will see these are the 8 pins of port 2. So under peripheral, you will see all the peripherals, serial. So that's everything related to serial. Timer, konta timer paije, timer 0, timer 1, everything related to timer. And this windows will remain, and when you execute, you will see the changes in the respective peripherals. Okay. So peripheral interrupt, everything related to interrupt is available. So that's how you can keep on executing, and you can keep on checking the registers, checking the memory, right? Right. So please try this on your own. Students, try doing subtraction of two numbers. Try to do it on your own, students, right? And we will discuss this in the next. So thank you, students, and we will see you in the second session. See you in the next session. Bye, students.